This is the first robotic theory lecture of the CAM 810S course. Nearly 100 years ago, the Czech writer Karel Čapek wrote a science fiction play which he called Rossum's Universal Robots. In this play, artificial people, called robot in Czech language, played an important role. Robota is a Czech word for worker or forced laborer. The International Organization for Standardization, ISO, gives the following definition of a manipulating industrial robot. It is an automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes, which may be either fixed in place or mobile for use in industrial automation applications. The first industrial robot arm was developed in 1954 by the two American engineers George DeWall and Joe Engelberger. They called it Unimate. 7 years later, the US car manufacturer General Motors started to integrate Unimate robots in car assembly lines. What does a robot arm do? It moves, manipulates, and handles objects, tools, and special devices by means of pre-programmed motions to pre-programmed points. The reasons for installing industrial robots, there is quite a number of them. The high flexibility of the production which can be achieved. Optimized workflow. For humans, the relief of dangerous operations. Robots can work for 24 hours without getting tired. Once set up and programmed, robots perform a job always with the same high quality and in an absolutely safe way. Let's look at the details for the human beings. Humans can be relieved of dangerous and unpleasant working conditions such as excessive heat, excessive noise, poisonous gases, risk of injury by machines, monotonous, repetitive, and boring work, and extreme physical exertion. The main components of a robotic system are, look at position 1 and 2. These are control elements. Positions 3, 4, 5, 9, and 10 are components of the robot arm. Positions 7 and 8 are periphery devices. And position 6 is a safety device. We're now going to look into the details of all these components. The kinematics of the arm allows to move objects in the workspace of the robot. It is composed of axes, arms, joints, links, and guideways. The drive system, mostly electric and mechanical, in some very few cases also hydraulic, is composed of motors, power transmissions, levers, clutches, and brakes. There is a measuring system which determines location, speed, and the load of the axis. It determines also the position of the effector and controls trajectory and speed. It is composed of encoders, speed sensors, proximity sensors, and force sensors. The controller controls the sequence of the movements and the safety of the system. Its components are a control panel with a display. Inside there are microprocessors, there is a memory, there is a signal converter, there is an amplifier, and there are inputs and outputs so that the controller can communicate with its surroundings or with its periphery. The program defines the task of the robot. It can easily be modified or changed. There are commands for position definition, for manipulation, for program flow, and many others. External sensors provide signals from the robot cells, means from the periphery, from the surrounding. There are different types of sensors. A very important one of them is our vision systems. Periphery devices are auxiliary equipments they are used for part transfer to and from the robotic cell. There are part feeders, conveyors, clamping devices, rotary tables, and others. Most of them you have learned something about in the previous lecture, last lecture of the CAM module. A handheld control and programming unit called Teach Pendant facilitates the teaching of positions and programming. Safety fences, such as, for instance, a solid modular wire mesh barrier, as in this case, restricts the access to the robotic cell and makes it safe for humans. A robotic cell is an excellent example of mechatronics. Mechatronics is the combination of mechanical, electronic, and IT engineering. Each component of a robotic cell interacts with one or several other components. You will find this diagram on exercise robotic 1 sheet. So study it and describe the interaction of the components. This is the end of the first robotic lecture. Thank you for your attention.